Ciao a tutti, mi chiamo Sofia Tancredi. I am presenting a third speed project, the Balanced Number Line. This is part of a larger project called Balance Board Math. The balanced number line is a new way of interacting with the math concepts of absolute value and negative numbers using the sense of balance. This project is motivated by improving instructional accessibility for learners who crave movement. Some learners, especially many learners with ADHD and learners on the autism spectrum, need more movement stimulation than is typically offered in the classroom in order to regulate and attend. A key feature of this project is that it reconciles two ways of thinking about movement in learning: sensory regulation and embodied cognition. I'll explain what I mean by that. First, sensory regulation. Theories of sensory regulation in the psychology and occupational therapy literature posit that movement operates as a means to maintain optimal levels of alertness through sensory stimuli that are adaptive to one's sensory profile. For example, if I was whispering to you right now, you might eventually start to get tired and lose focus on what I'm saying. In that example, the sensory input is auditory. In this project, we're looking at another kind of sensory input: balance input to the vestibular system in the inner ear. The vestibular system supports balance and coordination. It includes three semicircular canals in different orientations, X, Y, and Z, that detect our movement. Here's an example of a movement that stimulates the vestibular system. In this GIF, two people rhythmically rock back and forth together on a couch. Unlike this, sitting in the classroom doesn't stimulate the vestibular system much at all. Students who need more vestibular stimulation might try to get it by rocking in their chair or walking around, which might look to their teacher like they're distracted. Does sensory regulation matter for education? There's evidence for the impact of sensory experience on academic learning. Sensory differences have been found to explain 47% of variance in academic performance for children on the autism spectrum. And self-directed movement, like fidgeting, is positively correlated with performance for children with ADHD. Based on this project sets forth from the perspective that having a learning task and environment that meets one's sensory regulation needs is a question of accessibility. So that's sensory regulation. Where does embodied cognition come in? Dorr described earlier how movement plays a central role in cognition. The vestibular system plays a central role in movement. Not surprisingly, then, the vestibular system has also been implicated in cognitive development and even abstract reasoning. Existing solutions in the United States for supporting sensory regulation typically meet sensory needs separately from academic learning, either by providing sensory accommodations to students in the classroom, such as specialized seating, or through therapeutic sensory programs conducted outside of the classroom. But according to embodied cognition, sensory activity is part of cognition, not happening separate from it. The ways that students move in classrooms impacts both their sensory regulation and their cognition. This project differs from previous solutions by treating sensory regulation as part of mathematical activity. The design conjecture of this project is that directly incorporating vestibular stimulation into learning activities will improve their efficacy. To illustrate this, we see here a boy standing on a balance board and separately a set of number lines. The balance number line combines these two things: the sensory regulation tool of the balance board with the number line tools from math instruction. The result: the balance number line. The balance number line makes rocking on a balance board central to a series of mathematical learning tasks. Students rock on the balance board by moving their hands along a number line in front of them. Here we have a boy sitting on the balance board and facing a number line. He slides his hands along the number line in front of him. His movements cause shifts in the board's balance, providing stimulation to the vestibular system that serves as feedback about the placement of his hands. Here's an example of how moving your hands impacts the balance board. In this GIF, my hands start together at 0. Then my left hand moves more and more left into negative numbers. As my hands move, the board tilts more and more to the left. The design builds on learners' natural engagement with vestibular stimulatory behavior. Rocking becomes a resource for conceptual learning. The balanced number line is designed not only to support sensory regulation, but also to use vestibular stimulation to enhance the perceptual salience of learning relevant stimuli. An example of one balanced number line activity is to find a way to move both your hands along the number line while staying in balance on the board. What do you think the solution might be? Okay, here's the solution, solved in this GIF by a 13-year-old student on the autism spectrum. He moves both hands apart at a set rate, keeping them equidistant from the origin, for example, at -2 and 2, -4 and 4, etc. In this second GIF, I demonstrate the hand movement facing the camera so you can see that the board stays flat throughout the entire movement. Solving this problem develops a sense of number line symmetry. Negative numbers are defined as the counterbalancing point to their positive counterparts. We can use the numbers on the number line as tools to help control and talk about our solutions. Balance board math started out with the simple idea of relating movement on a number line to a balance board. The first challenge was how to get hand movements to translate to a clear change in the board. It turns out that sitting down works best. Here's a kind pilot participant trying an early prototype, sitting on the board and moving his hands along a piece of tape number line. Another key dimension was how to be able to document and talk about movements mathematically. I made a simple wooden number line and magnetized it so that learners could place magnetic arrows to describe their movements. With the basic mechanisms for doing and talking about mathematical movement in place, I incorporated feedback to improve the sensory and motor joy of using the board through things like using a larger surface board with a carpet and incorporating lights into the number line that respond to your movements, adding another modality of engagement. Currently, I am working on expanding this design to explore other mathematical concepts like functions and angles, as well as ways for learners with different sensory profiles to learn together. This project is still ongoing, so there's much more to learn, but here are a few ideas right now that might be relevant for the classroom. 1, different learners within the same classroom will need different levels of sensory stimulation to do their best learning. 2, students who are moving in non-prescribed ways, such as fidgeting or tilting in their chair, might actually be meeting their sensory needs in order to work. Recognizing what sensory systems they are stimulating can help to offer alternatives that are not disruptive to their peers. 3, engaging foundational sensory systems like the balance, tactile, and proprioceptive systems through movement-based activities can support students' attention and self-regulation. Thanks.